More definitions. One-to-one. So one-to-one will feel kind of similar to what we were talking about with the definition of function. It's a function, but instead of talking about one input has to be mapped to a single output, now one output can only be mapped to a single input. So a lot of those examples that we saw at the beginning, if you want to go back and look at it, a lot of those examples were not one-to-one because we had those two outputs being mapped to, or we had an output being mapped to two separate inputs. So for this first equation, actually that might be from the first slide. I think it is. Well, we already saw it. It's a function. I have my inputs. I have three different inputs, so they can't be mapped. I can't have a single input going to two outputs. So boom, it is a function. Well, now we have to think, okay, is my function one-to-one? Well, we look at the outputs in this case. My outputs are -2, 5, and 5, so now I have repeating outputs. And my repeating outputs are mapped from two separate inputs for a -3, so this is not one-to-one. It is a function, but it's not one-to-one. Where in this case, okay, I have -2 being mapped to 1, I have 1 being mapped to 5, and so every one of my outputs only has a single input, so we're good to go. That is one-to-one. I don't know why I'm missing my hyphens there. Now there's a couple of ways to determine if a relation is a function and if it's one-to-one when looking at a graph. So if you have a graph, these are actually really nice and quick tests. And honestly, sometimes if you have a function and you're pretty good at graphing, it's not a bad idea to graph it and then use these tests to determine if it is a function or not, or if it's one-to-one or not. And so these two tests are named the vertical line test and the horizontal line test, which makes sense because one-to-one and the definition for one-to-one and the definition for function are so close to each other that the tests should be so close to each other. And how the tests work is, for vertical line test, we'll focus on that one first, is that if you can draw any vertical line that would intersect your graph in more than one spot, the graph is not a function. So these tests, you're trying to prove something is not a function. And very similar, horizontal line test, if you can draw any horizontal line in your graph and it intersects your function in more than one spot, then it is not one-to-one. So to see it in practice, this leftmost graph, I'm going to try and use the vertical line test on it. Okay, well, I drew a vertical line there. It's only hitting 1 point. One there is only hitting 1 point. One there is only hitting 1 point. I can play this game all day, but eventually you can kind of arrive at the point of saying, okay, it doesn't really matter where I put that vertical line. It's only going to hit 1 point on my graph. So it's definitely a function. Now I'm going to determine if it's a one-to-one function. So I go through the horizontal line test, and at this point almost like ignore those red lines. Now I'm moving on. I'm only concerned about that blue diagonal line. So I draw a horizontal line, only intersects that f of x function once. Another one, and again I can do this all day. I will never intersect more than one, or my graph at more than 1 point, so it is one-to-one. I don't know if we can see the bottom of that, but I'll show the whole slide after. But all it's saying there is that it's one-to-one. Okay, second graph. Same type of thing. I draw a vertical line intersecting 1 point, draw another vertical line, intersects 1 point. You can play this game all day. There is no way that you can draw a vertical line that will intersect more than 1 point, so it is a function. But now let's go to the horizontal line game. So this first guy, yes, I can draw one line that would intersect 1 point on my graph. But look carefully at that definition and specifically what is underlined in that definition. This has to be true for any line you could draw. So even though I drew one line there, that's the only line I can draw that will only intersect 1 point. So as soon as I draw a different line, like right there, for example, that intersects my graph at 2 separate points. So that is not one-to-one. Last graph, same type of logic. Vertical line test, I'm trying to determine if it's a function or not. I can draw one line that would intersect 1 point. I could honestly draw another line on the other side of the circle that would intersect 1 point. But it would be very, very easy. I could give this graph to someone in 3rd grade and say, can you draw a line vertical that intersects 2 points, and they would almost do it immediately because there's so many options you can do it. So as soon as you can draw one line that intersects more than 1 point, not a function. And if you wanted to, you could go ahead and do the horizontal line test, but the truth of the matter is, if it's not a function, you can't really have it be one-to-one. You need something to be in function in order for you to even kind of start the conversation about whether or not it's one-to-one. So, I mean, you might be taking a not well-written test at some point in your future, and so they might ask you to determine if it's a function or not and whether or not it's one-to-one. But if it's not a function, it can't be one-to-one. Let me pull up that slide in case we can't see it. So this is what that's what we were missing, was the bottom part. So that first graph was 1-to-1, and the second graph was not 1-to-1 because we could draw that line that intersected 2 points as we saw. Okay, let's get back to it.